Welcome back to the maths lecture. Last time we had started working on the exercise 3.2, that is the polar coordinates and the Cartesian coordinates. We had completed the questions based on polar coordinates and Cartesian coordinates. Now we are going to start with the sine rule. Okay. First we will prove what is sine rule. After that we will prove what is cosine rule. Okay. And after that we will see projection rule. There are three rules over here. Okay. Based on that, few examples are there in the exercise. We will do them. Okay. So now let us see what is the sine rule. The sine rule says in a triangle ABC, A upon sine A is equals to B upon sine B is equals to C upon sine C. This ratio is equals to 2R, where R is the circumradius of triangle ABC. So let me write the statement of this proof. The rule in triangle ABC. Okay, what they're saying, we have A upon sine A, B upon sine B, and C upon sine C. Okay, this ratio is equal, and the total ratio is equals to 2R. Okay, whether you take A upon sine A, B upon sine B, and C upon sine C, you will get the value as 2R. Now we have to prove this. Okay, and what is R? Well, R is the circumradius. Okay, so now how to prove it? First of all, we will have to construct a triangle. A triangle with a name A, B, C. Okay. Now we all know the side opposite to angle A is denoted by small a. Correct? Means the length of this side is small a. The length of the side opposite to angle B is small b, and the side opposite to angle C is small c. Okay. Now there is a small construction over here. We will have to draw a perpendicular from A towards BC. Okay. Let's give the name as AD. Correct. Now, if you see, there are two right angle triangles formed inside the triangle ABC. Correct. Now, let's pick up the first triangle. In triangle ABD, in triangle ABD, sine B will be equal to what? Okay. Now, in 10th standard, we all have learned the formula. Sine theta is opposite upon hypotenuse. Correct? So what is opposite side of angle B? Opposite side of angle B is AD. Correct? Upon what is the hypotenuse? The side opposite to angle 90 degree. That is AB. Right? So what we can say, AD upon what is the value of AB? AB is nothing but small c. So therefore, what I can say is AD can be written as C sin B. Correct? Now, we got the value of AD as C sin B. Now we will come to the bigger triangle. In triangle ABC. Okay? We know that area of a triangle ABC can be given as half into base into height. Correct? Now what is the base here? BC is the base. And what is the height? AD is the height. So half into base. Base is BC. Height is AD. Correct? So half into. But we know the value of BC. That is small a. Correct? So A into. What is AD? AD we have already found out over here. AD is nothing but C sine of B. Correct? So we got to know area of a triangle ABC is half AC sine B. This has 1. Okay? Follow till here. Now after that, come to the triangle ADC. Sin C can be written as opposite upon hypotenuse. What is the opposite of sin C? That is AD upon hypotenuse is AC. Correct? That gives us sin of C equal to AD upon AC. AC is nothing but small d. So therefore, we can write the value of AD as B sin C. Correct? Now again come to the triangle ABC. In triangle ABC, what do we know? Area of a triangle ABC is half into base into height. What is the base for this triangle? BC is the base. Height is nothing but AD. But we again know the value of AD. What it is? B sin C. And what is BC? BC is nothing but A. So it will be half. BC is A and AD is B sin C. Give this as 2. Okay? This is nothing but area of a triangle A, B, C. Got it? Now, we have got two equations. Okay? These two equations are required to us. So, what I'll do, I'll write them over here. So, it will be area of triangle ABC is half AC sin B. That is my first equation, correct? And this is my second equation. Area of a triangle ABC is half AB sin C. Correct? Now similarly, we'll do it for angle A. Now for doing it for angle A, we need to draw one more triangle. Our same triangle it will be ABC of same length. Okay? But here we'll use a different altitude. Okay? A, B, C. This is my length A, this is my length C, and this is my length B. Okay? Draw one altitude from B towards AC. Okay? And let us give this as P. Okay? Now, again we have formed two triangles over here. Let's use the first one. In triangle APB, okay, sine of A is equals to opposite upon hypotenuse, right? So what is opposite? BP is opposite, and what is hypotenuse? AB is the hypotenuse. Substitute the value of AC. AC is nothing but, sorry, that's not AC, that is AB. Substitute the value of AB, that is C. So therefore, BP is equals to C sin A. Correct? Now again in triangle ABC, the bigger one, the bigger triangle I am taking. Area of a triangle ABC is half into base into height. Now the base is changed to AC because the altitude is landing on AC. So base is AC and the height is BP. Okay, so half into base AC means the length B into BP. We know the value of BP. Here we have calculated it. C into sin A. C sin A. So half BC sin A. Area of a triangle ABC. This is third equation. Now look at the first, second and third equation. What do you observe? The left hand side of all the three equations are same. Therefore, you can equate the right hand side of those equations. So let me write down the third equation over here. Area of a triangle ABC is half into BC sine A. This is my third equation, correct? So from 1, 2 and 3, what do I got to know? It's half AC. Let me write down sine A term first. Half BC sine A equal to half AC sine B equal to half AB sine C. Okay. Now once we get this equation, we throughout divide by half ABC. So what do we get if we divide by half ABC? Half BC sine A equal to half AC sine B equal to half AB sine C. Throughout divide by half ABC. Half ABC and half ABC. Right? So what will happen? This half will get cancelled. This half will get cancelled. This half and this half will also get cancelled. Okay? Now, BC will get cancelled with BC, AC will get cancelled with AC, and AB will get cancelled with AB. We will be left out with sine A upon A equal to sine B upon B equal to sine C upon C. Correct? Now, by inverted, we can write this as A upon sine A equal to B upon sine B equal to C upon sine C. Correct? This is what we were supposed to prove. Now, after this, one more thing we are supposed to prove is this ratio is equals to 2R. That is what is left out. But I hope everyone have understood till here. Okay? So let's give this as equation 4. Okay? Now after this, let's this ratio we have to prove that it is equals to 2R. Now to do this, we have to go back to the 10th standard and just recall one what we can say, one theorem which you have learned in 10th standard. Okay, that is in geometry. If we have a circle, okay, let we have two points A and B, okay, where AB is the minor arc, and if we draw an angle over here, let's call it as C, okay, then this angle C is half of this arc, correct? This angle C is half of the arc AB. This everyone agree? Now I draw one more angle over here. Let's call it as Q. Now if you observe, angle AQB has the same arc, correct? So if you observe here, I can write major angle ACB is half of major arc AC, correct? Also, major angle AQB is half of major arc AC. But if you see both this equation, I can see right hand side is same. So I can equate the left hand side. So what I got to know that if we have one or two or many angles from which the arc inscribed is same, for which the arc inscribed is same, then these angles are equal. Okay, they are equal to each other. Okay, so therefore angle ACB, that is this angle, is equal to angle AQB. So these angles are equal to each other. So this property we will be using here. Okay. Now let's draw a circle over here. Okay. We had a triangle ABC. That is our original triangle, correct? Using which we have started the proof. A, B, C. Now what we have to do, we have to draw a line passing through the center of the circle and touching the circle again. So basically, if the line is passing through the center of the circle, it's nothing but a diameter. Okay? Let's call this point as Q. Okay? And let's join this. This is my construction. This is my construction. Now, if you observe arc AC, observe arc AC. These two angles inscribe that arc AC. Correct? So therefore, what I can say, angle B is equal to angle Q. Correct? Just now we have seen the property. So using that, we can prove this. So basically, first, let's write down the construction. Draw a line from A passing through center and touching the circle at point Q. Okay. Now, if you see the arc inscribed by angle ABC and angle AQC are same. Therefore, angle ABC is equals to angle AQC. So basically what we can say, angle B is equals to angle Q. Okay. Taking sine on both sides. So it will be sine B equal to sine Q. Correct? Now till here I think everyone understood. Correct? Now after this, since it is passing through the center, this length is 2r. Correct? And this side is opposite to angle B, so it should be small b over here. Correct? Now in triangle AQC, okay, sine Q is opposite side upon hypotenuse, so that will be AC upon, see this is 90 degree. We cannot apply this rule unless the triangle is right angle triangle, and this has become 90 degree because if an angle is inscribed by a diameter, it is always a 90 degree. Correct? It is a right angle triangle. This property also you have learned in standard 10th standard. This is angle 90 degree. So that is why I can apply this rule. So sine of Q is opposite upon hypotenuse. So opposite to this is AC, and what is hypotenuse? AQ. Correct? But we know the length AC is nothing but B, and AQ is nothing but R. Correct? But here if you observe, sine B is equals to sine Q. But we got to know the value of sine Q. Sine Q is nothing but B upon 2R. So therefore, what I can conclude is sine B is equals to B upon 2R. Understood till here? Okay, excellent. Now after this, give this as equation number 5. Okay. So from 4 and 5, what we came to know is, see, we had equation 4 as a upon sine a equal to b upon sine b equal to c upon sine c. This was our equation 4. So from 4 and 5 we got to know that instead of giving this 5, what I will do, I will just simplify it and make it 2 are equal to b upon sine b. Okay. And now I will give it as equation 5. So from 4 and 5 we got to know that a upon sine a is equals to 4 and 5. A upon sine a is equals to b upon sine b equal to c upon sine c equals to 2r. This is what we were supposed to prove. That is our sine rule. Okay. Now, I hope everyone understood what is the sine rule. Okay. Now, let me define the cosine rule and we'll see the proof of cosine rule in the next lecture. Okay. So, I hope everyone understood what we have done in the sine rule. Right. Now, as a homework, what you people do, go through the cosine rule, what it is actually, how we have to prove it. Though I am going to explain it, you have to do it for the self-study for the next lecture. Okay? The cosine rule. Cosine rule says if we have a square, then it is equals to b square plus c square minus 2bc cos of a. Okay. Next is if you have b square, then it is a square plus c square minus 2ac cos b, and c square is equals to that is a square plus b square minus 2ab cos of c. This is the cosine rule. You have to memorize this. Okay, it's very easy to remember this. See, if we have a over here, we cannot have the small alphabet a over here. It's always other than a. It's b square c square minus 2bc. And then we have cos a. So whatever alphabet is here, the angle is the same. Same here, b. See the angle is the same, and we don't have a repetition of b over here. It's another than b. It's a square plus c square minus 2ac. Similarly, here c square is equal to a square plus b square minus 2ab cos c. Okay, I hope you all have enjoyed the session. The sine rule you all have understood. Now, go through the proof of the cosine rule. I will explain it in the next lecture. See you students, see you in the next class.